pencils. He was testing you to see if you were paying attention. All right, so we're going to look at some examples out of the homework. So this is the book that has a million questions. Like this particular section has 110, but we're not going to do all of them, but I am going to go through and pick some because odds are you probably haven't seen this particular stuff in any math book you've had before. So it says to identify the set, and then it gives us a set as finite or infinite. So number 6, we're given the set 1, 1/3, 1/9, 1/27, and so on. And it's on page 7.
You want us to write this down?
It's totally up to you, but tests and quizzes usually come from what I've gone over in class or from the homework problems, so. So is this set finite or infinite? Or what is your best guess?
Infinite.
Yep, infinite.
And then we'll just keep going. Just keep this going.
Yep, it keeps going. All right, number 8 gives you 2 sets. So the set U is the set 1, 2, 3, 4, 5. Okay, and that would be the universal set. And then set A is the set 1, 2, 3. And it wants us to find a complement. That's the little A with the apostrophe. So complement means everything that's not in A but's in the universal set. Okay? So basically what numbers are not in A but are in the universal set? Any ideas? If I take away basically 1, 2, and 3 from the universal set, what am I left with?
4 and 5.
Yep, 4 and 5. So the complement is always going to be anything that's not in there but is in the set as a whole. Let's see, 10 says to find the set 16, 18, 21, and 50, union with the set 15, 16, 17, and 18. So union means everything that's in both sets. Okay, but we don't write anything twice. So like in this case, Number 16 and number 18 are in both sets, so we're only going to write them once. Okay? So the union of this,
16 and 18.
it's everything. So intersection, which is the one that looks like this, okay, that would be, if we had the intersection of those two sets, would be 16 and 18, because that's the only thing that's in both of them. Okay, but union is everything that's in them together, basically. So this would be 15, 16, 17, 18, 21, and 50. And so then, just so that you have it for reference, I'm going to just rewrite it, but with the intersection of them, I just copied it. So the intersection is, like if you've ever seen a Venn diagram, the intersection is the middle part that overlaps. So the intersection is our overlap, which is 16 and 18 in this case, because those are the only two numbers that are in both sets. So this one would be that. All right, so the next set of problems, so those were all just kind of like concept preview questions that just kind of like wanted you to get like a general idea of what was coming. So these say to identify each set as finite or infinite, so that's kind of like the first problem that we looked at. Then determine whether 10 is an element of the set. So basically it's like, given the information that we're given, is 10 going to be included in that set? So number 12, we have 1, 2, 3, 4, 5, ... 75. So whenever they do a ... you assume that the pattern continues like it was. So like if they had been counting by twos, we would assume they kept counting by twos all the way up until whatever the capped number is. In this case, they were counting by one, so our assumption is that that ... is 6, 7, 8, and so on and so forth, all the way up to 75. So based on that, is this set going to be finite or infinite?
Finite.
Yep. Finite because it has a definite start and a definite end. And then it wants to know if 10 is an element of the set. So is 10 in this set?
Yes.
Yep, it's part of the ... So when we do that, you will often see me write it like this. And this symbol here means element of. So under the same instructions, this problem just looks a little bit different in how they write it. Number 18, it's x such that, so this line means such that. And sometimes if you see me write it, like if I was writing it out in words, you would see me write like s.t, just so you know, that's what that means. So x such that x is an even natural number. Now, do we remember what natural numbers are? Basically just whole numbers, yep.
Alright. Thank you, but
Alright, so is the set of even natural numbers finite or infinite? Infinite, because we have no idea what the last number is. And then based on that, would 10 be an element of this set?
Yes.
Okay, yep, because it is even. Any questions about those ones so far? Okay. All right. These next ones say use set notation and list all the elements of each set. So basically, they're giving you a ... area to fill in, and you have to figure out what their pattern was that they were counting by to fill in those numbers that are missing.
You just do like 3?
Hmm?
Just do 3 or like all of them?
However many are missing, but they're not, most of them aren't missing that many. You have to like write the whole set out, so you'll end up writing all the numbers, but you're only filling in like 2 or 3 typically, yeah. So 24.
As long as we don't get 22.
Well, that one,
Yeah,
they're
I thought
just
it was 1, 2, 3.
multiplying by 3
Yeah.
every time.
That's actually
All right, 24. We've got 74, 68, 62, ... 38. So what are they, and I'm just going to say generically, adding, subtracting, multiplying, dividing, like by, like which method are they using, and then what is the number? So how are we getting from 74 to 68?
-6.
-6, and then always check and make sure that 68 to 62 is still the same thing before you just start subtracting, because it could be a pattern of like -6, -5, and so on and so forth. This one's not, but always want to check. So I have 74, 68, 62. What would be next?
The 6.
56. And then
Oh yes, 50.
this is a very interactive class, so then what?
44.
44, and then finally we're down to 38, so we can stop. All right, so 26, again, written a little differently. It's x such that x is a natural number not greater than 4. So what would that entail? We said natural numbers are basically whole numbers,
So 1, 2, 3, 4.
not greater than 4.
Not greater. Yeah, 1, 2, 3, 4. Okay. Not greater.
So it can't be bigger than 4. It's only going to be 1, 2, and 3.
Oh, 1, 2, 3. It's 4. Oh.
Well, I guess it doesn't say or equal to. So yeah, technically 4 would be included. If it said not greater than or equal to, then we couldn't include it. But yeah, since it's just greater than it is, we would include it. All right. Questions about those ones? Feel okay with those? Cool. All right. 28. So these ones say to insert. It's this symbol, element or not an element, basically. So we're deciding if the number that's given is an element or not an element of the set, basically. So 28, 9 blank, the set of 2, 3, 5, 9, and 8. So is 9 an element of that set?
No. Yes.
Yes, because it is in the set here, so it is an element of. Now, this next one, 34, is the set of 5 blank, the set of 3, 4, 5, 6, 7. So is the set of 5 an element of the set 3, 4, 5, 6, 7?
Yes.
No.
Which is on
It's its own set. So the only way it would have been is if this had instead had that around it. So because it didn't, it is not an element of.
I'm really struggling drawing these little.
Yeah. My left ones always look better than my right ones. However, I have done them for a really long time. Last year, I think it was Lorelei. She just sat and practiced them. All right, so now it's basically the same thing, but they are telling us that either the sets are an element of, they're not an element of, or that they're like equal to, and we're saying true or false. So instead of us having to fill it in, they've already filled it in. We're deciding if it's true or not. So 42, 12 is an element of the set. Oh, that was bad. 18, 17, 15, 13, 12. So is that true or false?
True.
True. All right, 46 is the set 3, 0, 9, 6, 2 is equal to the set 2, 9, 0, 3, 6. And we want to know if that's true or false.
False.
It is true. It doesn't have to be in the same order, it just has to have the same elements in it. Then what about like 48? 3, 7, 12, 14, or the set of those is equal to the set of 3, 7, 12, 14, 0. Is that true or false?
False. This is 0.
False, yes, because the 0, so they are not the same. Okay, so these next problems, they give us a whole bunch of sets. So I'm going to write them all out once. When you do your homework, I would recommend you just write them like once and then do all the problems that are associated with that so that you're not having to write them every single time. So they give us that A is the set 2, 4, 6, 8, 10, 12. B is the set 2, 4, 8, 10. C is the set 4, 10, 12. D is the set 2 and 10. And then the universal set, U, is 2, 4, 6, 8, 10, 12, and 14. So these are true-false questions. They go with these ones, and then we'll have another set that we'll write down a whole bunch of to do another set of problems in a little bit. But so 52 has that C is a subset of U. So to be a subset, it basically says that everything that's in C also has to be in U. So is everything in C also in U?
Yes.
Okay, so this would be true. Then with 56, this one is that B is a subset of C. So is everything in B also in C? No. So it is false. All right, I'm going to see if y'all remember what from the thing. You remember what that symbol is? I think it was in there. Might not have been. Might be asking you a trick question. Oh, no, it isn't there.
There's nothing in the set.
Yep. Set containing no elements. So is the empty set a subset of the empty set? Yes. That would be true. So now the next problems are fill in the blank problems like these ones, 28 and 34 were. But now we're doing it for subset. Okay, so it'll be this symbol or it'll be this symbol with a line through it, meaning that it's not a subset of. So 64, the set 1, 5, blank, the set 0, 1, 2, 3, 5. So is the set 1, 5 a subset of the set 0, 1, 2, 3, 5?
Yes.
Yes, it is. So we put our little subset symbol in there. Then 66, the set 5, 6, 7, 8, blank, the set 1, 2, 3, 4, 5, 6, 7. So is the set 5, 6, 7, 8 a subset of the other? No. Why not?
Because it said no 8 on the right.
Yep, there's no 8 on the right one, so that is not a subset of. Any questions about subset? I feel like that typically ends up being the part that people understand the least out of this section usually. You're okay with that? All right. So the next ones are again determining if the statement is true or false. So this is going to be dealing with intersection and union. So intersection is everything that's in both sets. Union is everything that's in either set, basically. So like everything gets written down in a union situation. So 70, we have the set 8, 11, 15, intersected with the set 8, 11, 19, and 20. And they say that that's equal to, so basically that the intersection is equal to the set of 8 and 11. So basically with these, you're looking for, are those the only elements that are in both of these sets? Yes. So that's going to be true. Then with 74, we have the set 6, 8, 9, union with 9, 8, 6. And it says that that's equal to 8 and 9. So union should be everything that's in both sets. So, is this true or not?
True. Right.
It's missing 6, right?
Yep, it's missing a 6 for this to be completely true.
Wait a minute.
So this is false. If there was a 6 here, or somewhere in there, it would be true. Because the union is everything that you see in there gets written down one time. So usually your intersection sets are pretty small. Your union sets usually end up being pretty big. Unless it's a lot of repeats like this one. It'll probably make more sense with what we're about to do when it gives us all the numbers. So now we're going to actually do these by hand, which I, in some respects, think is easier than doing the, like, true and false. So we have, and again, this is where I would write them all down and then just use them from there on out to do your problems. The universal set, so this is going to be all the numbers that we're dealing with, 0, 1, all the way through 13, so I'm not going to say them all. So the universal is always going to be like all possible numbers you could have. Then they give us 4 individual sets after that. So set M is the set 0, 2, 4, 6, 8. The set N is 1, 3, 5, 7, 9, 11, and 13. Set Q, 0, 2, 4, 6, 8, 10, 12. And set R is 0, 1, 2, 3, 4. It's getting blurry. Also, if you ever notice the screen's like getting blurry, just let me know because I'm not always looking up there and this thing gets blurry a lot. Mine's a little older, so it doesn't like to stay focused.
Something not like that.
But, like, this is, like, showing you what's on my iPad. Because, like, I can take the iPad, like, away. But since I record it, I can't use, like, an Apple TV. Because that would be the best
Yeah.
case scenario. But I can't record and use an Apple TV. It's recording on my iPad. I screen record it with sound. Because it just, yeah, I don't know, makes it easier. The people, like, Algebra 2, I feel for them. I need to go back and redo those videos. Because literally they're watching videos that were recorded, like, with this, like, during COVID. And they were, like, on paper and my hand's in the way. Because, like, when you go back and watch this video, my hand, you won't see my hand. Like, you're only going to see what's getting written down. Obviously, in class, you see my hand because of how I have to do it. But it's like paper and markers, like, literally is how I was doing it before. They're like, I can't wait till we get to the digital ones. I'm like, yeah, I know. I need to redo them.
I remember college, my sister was watching videos.
Mhm.
Doing, like, the circle thing.
The unit circle?
Like, she hated it. I remember that. She, like, she was, like, trying to memorize it.
Y'all get to do that this year.
Really?
Yep. It's got 66 things on it you have to know. It's not that bad. I teach you the pattern to it, so it's not that bad. I figured out ways to teach it better over the years since I had her, because she wasn't my very first class that I taught it to, but I figured out methods, and I've had students give me methods that they think are helpful. And
Because that was when, like, my dad got COVID, so we had to go to my uncle's house and then come back to school. Or we would be out for, like, 2 months. Because he had to quarantine with him, and then have to quarantine another 2 weeks after.
and then if any of you tested, then you would have had to quarantine
Yeah.
again. Yeah, I remember that.
We just left.
All right, so number 82. So this is like the last set of problems that we're doing. They're all coming out of this last chunk. So 82 is the intersection of M and U. So some people like to write down like all the sets out, and that's fine, but I would just reference them up top unless you're like really wanting to rewrite them all. So the intersection, we care about everything that's in both sets. So what would the intersection of M and U be?
0, 2, 4, 6, 8.
Mm-hmm. Yep, so everything that's in M is also in the universal set because the universal is every number that we could have. '88 is M union Q. So union is going to be everything that is in the sets. Okay? So if there were, these two sets have a lot of repeats, so they're all going to get written down. But if there were not repeats, everything between the two sets is getting written down. And technically speaking, it doesn't matter what order you put the numbers in, but if you want to be oh so kind to me and write them all in number order, that would be greatly appreciated when you get to like the big sets. So what would be the union of M and Q in this situation?
0, 1, 2, 3, 4, 6, 8, 10, 12.
Are you looking at M and Q?
Oh, Q? Oh, shoot, I was looking at, wait.
M and Q.
Oh, shoot, I was looking at Q and R.
I was like, I don't know where you're getting one from.
So it'd just be Q. All of Q, right?
Yep, because M basically was all repeated in Q. So yes, so 0, 2, 4, 6, 8, 10, and 12. Let's see. 90 is going to be the complement of Q. So that means everything in the universal set that's not in Q. So basically go through Q and what is missing from Q that you see up in U.
One, three, five, 7, 11, 13. Oh,
I was going to say, I think 9 is missing. Whoa, that was about to be really bad.
oh man.
All right, 2 more. And then I promise we'll be done. All right, so the empty set intersected with Q. So intersect means what?
It's like, I don't know.
Everything in both. So is there anything that overlaps in the empty set in set Q? No, because the empty set has nothing in it, so there can't be anything that overlaps. So we would write this as the empty set, and it would be called disjoint. All right, this last one is a little harder, so we're going to kind of do this one in like 2 steps. So number 100, we have R union N intersect with M complement. So my personal recommendation for one like this is to do each piece individually because it's not stuff that was given to you. So I would find R union N first. So I would rewrite that, and then I would find the complement of M. Then I would ultimately go back and find the intersection. So what is the union of R and N? Huh? Yeah.
0, 1, 2, 3, 4, 5, 7, 9, 11, 13.
Yes. So then that's going to be intersected with, what would the complement of M be? Complement means what? Everything that's missing. So what is missing from M that's in the universal set? Okay, throwing this back up here now. All right, so now we have, this is the union, that's the complement. So now I need the intersection of those 2 sets. Okay, so we've done each part individually. Now we can do the whole thing as a whole. So what is my overlap now for this? What numbers are in both? Yep. 1, 3, 5, 7, 9, 11, and 13. All right, so this section probably has the most problems you'll get from me all year, just because it's such a wide variety of things. But what I'm going to do is I am going to, since we used pretty much the whole class today, tomorrow you will have time to do these problems in class. And that way, if you have questions also, you can ask me about it. I'm trying to talk and write at the same time. And then you'll also have time in class to do the notes that we'll need on Thursday.
How much time we have left in class?
Only like 5-ish more minutes, 5 to 7 minutes.